In this challenge, we'll explore the basics of decision trees and random forests in the context of predicting outcomes using the Space Titanic dataset. Think of decision trees as simple step-by-step guides with a clear structure. They are like the building blocks for more advanced methods called random forests. We're going to see how these methods are really good at figuring out if someone survives or not in the space version of the Titanic. Our code helps us understand how decision trees and random forests can be great at sorting things into categories and giving us useful information about what factors are important for someone's survival in space. We'll get our hands dirty by playing around with these algorithms, figuring out which features matter, understanding how the models make decisions, and seeing how combining many decision trees can be super powerful. The Space Titanic dataset is like the stage for our exploration. It's not just theoretical. We'll use real-world data to see how well these techniques work. So, get ready to dive into decision trees and random forests, have fun selecting features, interpreting models, and learning about ensemble methods. What is a decision tree? Decision tree is a supervised machine learning algorithm used for both classification and regression tasks. It represents decisions and their possible consequences in a tree-like structure. It makes decisions by mimicking the human decision-making process by making decisions based on the values of input features, while a random forest is an ensemble learning method that builds multiple decision trees and merges their prediction. By merging its data, we can expect it provides high accuracy and perform well on a variety of datasets. The code performs several data preprocessing steps, builds and evaluates decision tree and random forest models, tunes the random forest model using grid search key, visualizes feature importances, and finally makes predictions on the test data for submission. The following are the basic idea of how the code runs. We start by import necessary libraries and load the training and test data from CSV files. We then apply feature engineering, split the data into features and target variables. We then train and evaluate the decision tree and random forest models, improve the model by tuning the hyperparameters of the random forest model using grid search key. And last but not least, we train the final model and make predictions on the test data. For the submission result, the performance of decision trees and random forests depends on the specific characteristics of your dataset and the goals of your predictive modeling task. We notice that if interpretability is crucial and the dataset is relatively simple, a decision tree might be sufficient. But if accuracy is a top priority, especially in complex datasets with many features, random forests are generally preferred. In the case for the Space Titanic dataset, a decision tree provides better generalization, robustness, and accuracy. You can see the details in our report. Thank you.